Okay, so let's see. Uh, yeah, what I did, you may remember that last time I forgot to turn on the record button, and so that means that there's no recording of our class last time, which is a drag. Um, so what I'm going to do is I'm gonna post the recording from the morning session to YouTube, and then you guys can see it from there. So I hope that helps. All right. Well, why don't we get started? And if other people come, that'll be fine. Good, good. Okay. So last time we talked about different announcements and stuff, and the big one is this gate review number one, which is next week, and that's Monday and Wednesday of next week. Let's check to see if people in your class have actually signed up, and we go to the discussions, and nobody has signed up. So you guys need to, present your gate review to me and the rest of your class. Everybody wants to see what people are up to, I'm sure. And so the way that we'll do that is through the discussions. And remember, I'll let you share your desktop, and you get to talk to us and tell us about what your project is, and all good, who's in your group, and all those kind of things. Um, and that'll be our first gate review of three. Remember, our next one is going to be the end of October, and then our last one will be about a month later when I'm in Pristina again. So that'll be fun. I'm looking forward to that. Remember what gate review number one is all about. And it's really just kind of all about talking about what your project is and how is your team organized. This is your first chance getting things organized and putting things together. So who are the members of your team and what are their roles? Important stuff. Uh, figuring out teams and everything, that's all good. Describe the nature of your project. What do you want to do? What's the project, and how are you going to approach this thing? What's the scope of your project? This is an initial try at putting some limits around what's part of your project and what's not part of your project. And so this will be your first time to do this, and it's okay if you decide to change this later on. The whole goal of gate review number one is not to present a finished, this is exactly what we're going to do. It's to put some things down on paper to say, this is what we're thinking about right now. Just like in any agile project where we do iterative development, things change over time, and we plan things, and we try things, and if they work, they work. If they don't, we come up with a new plan. And while this is more than just a throwaway kind of a thing, it's not as though it's cast in stone. So hopefully the members of your team are cast in stone, and the members of your teams have decided, we're going to work together. We get along well. We're going to do this together. We're going to stick it through together. We're going to be a team. But other things about it can change. The nature of your project. When you first start thinking about a project, you may have a different conception of what the essence of your project really is compared to after you do some research, after you talk to some people, after you dig into it a little bit more. You may realize, hey, there's more to this than I thought, or It's just different. And you know, that's fine. That's okay. Do any companies do something similar to what you're proposing? As you start working on stuff, you're going to find other things out there, and that's okay. And I expect that to happen, and that's all good. Uh, this next one, what's the hard part of your project going to be? That's important because I want you to think about the actual building of this stuff. What does it take to go from just doing little projects in your classes that, you know, people have been doing for a dozen years to coming up with something on your own? That's a different thing. And as you start digging into the project that you're working on, you're going to find other people who've thought of this also, and that's okay. Uh, and you should learn from what their thoughts have been and incorporate their thoughts and their experiences into your project as much as you can. What are the risks that you've identified around your project? Well, a lot of that is going to be about that hard part. One of the main risks is always, can we get the hard part to work? Or is it just too hard? Maybe there's a reason why nobody did this before. And so, you know, one of the main risks is going to be, do we have the chops to figure out how to get this to work? And so that's one of the risks. Another risk is going to be, you know, around money. Do you have enough money to buy the cloud infrastructure that you need to build your thing? Um, Another risk is going to be, will the group stay together? It may be that you know, somebody can't enroll in classes in the spring. That happens all the time, and you know, sometimes it's because of something else happened in their life. Other times it's just out of their control, and you're going to lose half your team. That's a drag. That's a risk, and so identifying those risks is an important thing. And then a general overview of the architecture you envision using. That's largely what we're going to talk about today. Is I want to talk to you about two real things. One is what kind of architectures do people use in large web scale applications, and why do they use that? And the other is what how much of your project do you actually need to build? If you are building an e-commerce site and you know you've got a good idea for what it should be and all those kind of things, well, do you need to build a point of sale system? Do you need to build an inventory control system? You need to build all of those sides of things. Well, you may because you want to, or you may not because you may go out and look at some of the open source e-commerce systems. You know, WordPress has an e-commerce system that you can, you know, kind of turn on and use. Does that mean you can't use that as part of a project? No, not at all, because your project would just change. The hardware and software that makes it so that you can buy and sell things is, generally speaking, not the determining factor on whether or not an e-commerce site is successful or not. There's a lot more that goes into it. And so you may want to say, we're going to rely on this e-commerce site to provide back-end functionality for us, but we're going to spend most of our time working on front end stuff. We're going to, you know, build out a really nice website. We're going to build out a customer notification system. We're going to combine what's that MailChimp as a way to interact with our customer on a more frequent basis. We're gonna do all these other sides of what makes an e-commerce site successful. I love it. That's great. You don't have to do the hardcore back-end functionality. And we're going to look at some IoT systems and those kind of things too, to think about what is it that we actually need to build to use this technology as part of our project? Last time we talked about minimum viable products. And I said, that's really what you're going to build as part of this class. And I think that's true. And so, as you build out the project that you're going to build, you're going to find that you're going to be thinking about these kind of issues in the back of your mind. Can we use the system to test a business concept? If the business concept is an e-commerce site that specializes in Kosovo made fashions, is that realistic? Is there enough of a market for Kosovo developed fashions to make this a useful project? What are the valuable customer insights that you might gain? Where you might find that people say, well, we really rely on pictures of what people are wearing in Paris to determine, what we wear on a daily basis here in Pristina. That's okay. Uh, how would you go about changing that? There's a famous guy, and I just saw his book the other day. What was his name? Bill, oh, I just blanked on his name. Uh, he was a kind of this esoteric guy who rode his bicycle around New York City, and he took pictures of fashion that he saw on the street. And he did this for like 50 years or something like this. And he published several books of his photographs and his stories and stuff. And people loved him. And it was a real thing. I think the New York Times used to publish some of his photos, and you can imagine how exciting it would be to have your picture of your fashion choices show up in the New York Times. And is it Bill Campbell? No, and so way cool stuff. That having that side of the business where you have a roving photographer walking around the streets of Pristina documenting fashion, that might be an essential component in Kosovo based fashion e-commerce site, because it may let people see what other people are wearing, and that may be a good thing. I don't know. It's just an idea. Validate market demand. Is there a market for what we're trying to do here? And then all of this at a minimal investment. So an MVP is what you're going to be building, and the thoughts around what the goals are for an MVP is a useful thing for you to think about. And, we talked about this already, and we talked about this. And this is really the way the class is structured. You're thinking about the market, and you're thinking about a problem that you want to address as part of a project. You're not going to be able to build a full-blown product, because a full-blown product, the difference between an MVP and a full-blown product is that a full-blown product is made to address all of the edge cases. It's made to handle all of those weird things that users do. You're not going to have time for that. So you're going to have to prioritize which features you think would be most important to your user base, and which would be of less importance, because you won't have time to develop all of them. And that's okay. Mapping the user journey. You're going to have to think about, how is a user going to flow through this application? Where are they going to start? How are we going to entice them to look at later pages? That's a key metric for a lot of e-commerce sites, particularly. Do people come to our site, look at the first page, and then leave? Or do they come to our site, look at the first page, follow a couple of links down into a few more pages, and maybe, put stuff into a shopping cart, maybe not, maybe buy something, maybe not. But if we can entice them to come and go to several pages within our application, we've done a much better job of capturing the users that we marketed to than if they just come to that first page and leave. And that's an important thing. Let's see, and that's part of mapping the journey. Developing the MVP. The MVPs, by definition, is a working piece of software, something that does something. Um, Instrumentation in MVP is really important, and collecting feedback from users that says what people like and what they don't like. And then analyzing what's our feedback say, and then figuring out the features that we're going to use in later iterations. My hope is that in the springtime, you will develop a working piece of software, and then two or three other features and two or three other sprints that you might work through to add more features to your application. We'll see how we do. And we looked at this, and we said that preparation design, that's a large part of developing an MVP. Figuring out what the problem is and how we're going to address it. And we talked about this. Okay. And use cases, we're going to talk more about, particularly as it relates to gate review number 2, because that's where we're going to talk about use cases and requirements as part of your application. And database design. So here's the problem. The problem with database design is that it usually needs to be done pretty early on in the development phase, even though you don't know that much about the problem yet. And the reason that's the case is because, one of the things we have to figure out is what objects are we keeping track of, and how are we going to describe those objects and attributes. That's our database. And what's the relationship between those objects? Well, it might be hard later on to include a whole new object into our database design. And so it's a tricky thing. So let's talk about an architecture that you might use in a web scale application. Web scale applications are different. And we've talked about the other classes. I do lectures about the market capitalization of some of the biggest companies in the world. Well, most of the biggest companies in the world are IT companies. It's NVIDIA, it's Google, not Google, it's Alphabet, Amazon, and those kind of companies are the biggest companies in the world. Why are they so big? Well, one of the reasons why they're so big is they figured out an architecture that was scalable. It gets big when it needs to get big, and it gets small when it needs to get small. And there's a lot of load, it's got to get big. But sometimes there's not a lot of load, and we don't want to pay for those servers anymore. So we want to scale it back when there's not a lot of demand. It's resilient. It's able to handle the craziness of the internet, where things come and go, and components fail, and bad things happen. But a good web scale application doesn't have one component fail and the whole thing just poof goes away. A good web scale application will fail gracefully. It will, a component will fail, and the application will say, well, I can't do that part right now, but I can do these other things. And so I'm going to keep accepting incoming user sessions, but I'm just going to tell them that, this one component doesn't work. And you know, that's okay. And we'll bring it back up when we can. Well, booking.com, has anybody ever used booking.com? No? All right. Have you, Arinda?
Yes, Professor.
Cool. What do you use it for?
To book like hotel if I'm traveling somewhere. It
Hmm.
was easier to find hotels near the center or wherever I wanted to.
Very cool. Yeah, you know, that's one of the things that it's made for. I don't think you could do plane reservations, plane tickets and stuff on booking.com. But, you know, you can do these things. You book a hotel, same with Tony. And so, whoops. And so, you know, that's what booking.com does. Well, let's look at some of the workload on booking.com. In 2019, the platform was handling 150 million or 1.5 million experiences booked every 24 hours. Well, that's booked. When you think about going to a different city and finding a hotel, you don't generally pick the hotel you're going to book right away. Generally speaking, you look at one, you compare it to another one, you look at pricing on one and pricing on the other, and then you look at the locations, and you know you're browsing around a lot and looking at a lot of different hotels. So this, you know, 1.5 million experiences booked every 24 hours, that doesn't get anywhere close to describing the real workload on the booking.com site, because most of the workload comes from search and from browsing. And and so, you know, this is a busy application. And they have over 100 million mobile users in 2022. And, you know, it's crazy how much workload there is on this one application. Is this a tremendously large application for the internet? No, it's not. It's pretty regular sized for successful applications on the internet. And that's the kind of craziness around this. So how do they support this? Come on, move on. The way that they support this is with what's called microservice architecture. And so as we see connections coming in from our content distribution network, this would be our users connecting into our application. A CDN is just a way to push our content all around the world to different servers around the world so that it's closer to our users when they come to log in to, you know, to see what we're doing. So if you access booking.com from Tokyo, you would access servers that were local to Tokyo, and you would get a much better performance and experience compared to accessing servers based in New York. That's just the way the internet works. Distance matters. Well, when a user connects into our user admin system here, it connects into an API gateway. And what that API gateway does, it says, what do you want to do? And then it forwards it to whichever the microservices make sense for what the user's requesting to do. Now, where's our web servers on here? They're probably kind of out here. This is where the web servers are, out in front of the CDN. The CDN pushes the content around the world to different sets of data centers with web servers and stuff. And then accepts the incoming requests, which then uh, hit this API gateway, and then we pick the service that it needs to go to. So if you wanted to look for a hotel, you might go to be pushed over to the search service, which would then send you to the hotel service. The search service would be different because it's going to be asking things like, where do you want to go? And what part of the world do you want to go to? How many people are in your party? What experiences do you want? Do you have any special needs? All of those things go into building the queries that run on Elasticsearch that then get results sent to Kafka. Kafka is a tool that pushes data around within architectures, and then it would come back with the results, probably from the MySQL cluster up here, then the Redis cluster up here, and this would be the hotels that they would show you. And that's all good. On the other hand, once you have found a couple of hotels, I first I looked at 10 different hotels, and I narrowed it down to 3. What I want to do is I want to look at the reviews of those hotels. And that would send you back out into another microservice, which would be the review service. Now, the review service is going to be way different than the hotel service. They're going to be linked together because the reviews are about different hotels, but they're a very different kind of a service. And so these services here are very, very different, let alone the booking and payment and booking management systems and stuff down here. Also very different. So why is this important? Because once again, I said that resilience was important here. So in the face of bad things happening on the internet, what should happen if our review service goes down? We get hacked, the server goes down, whatever bad things can happen there happen, as they always do. The question is, could the hotel service still provide you listings of hotels, even if you couldn't read the reviews? And the answer is yes. And that's a profoundly important part, because what it says is that these different services are not so tightly coupled so that one service failing takes down the entire architecture. And that's how we stay in business in the face of the craziness of the internet. And that's really important. Now, the other thing that's really important about this is that these are different kinds of services. The hotel service has this Redis cluster. Well, that's a different kind of a database than a MySQL cluster. And it's a different kind of a knowledge for the people that work on the hotel service than the people who work in Elasticsearch. They have a different knowledge base. They have different ideas of how applications work and how to interact with the APIs and all of those kinds of things. So how does Facebook employ 15,000 engineers to all work on the same code base? Well, the answer is they don't. They don't all work on the same code base. The Facebook service has been broken up into a large number of microservices, just like here. And those Facebook software engineers only work on the service that they know the best. And what that allows them to do is to have each individual microservice managed and maintained by a much smaller group of people. And as always, computing problems come down to not being technology problems whatsoever, but they're people problems. And so, how do we get the people that run the search service to talk to each other and exchange information, help each other out, and take ownership of the search service? Well, one way that we do it is we break the search service down into a number of smaller microservices that can be run by a small group of people. How small? Well, for Google, Google talks about it as their microservices are sized around the number of people that are needed to maintain them. And for Google, what they say is that your services shouldn't be any bigger, than the size of the having a two pizza team manage the service. And so, having a two pizza team means that, if we can feed the whole team based on just having two pizzas. Now, I don't know how big pizzas are in Palo Alto, and I don't know how hungry the people are in Palo Alto. My guess is that's going to be someplace around, say 8 and 12 pizza on people on each team. The advantage to having teams that size is that you get to know each other. You know who's good at doing this part and who's good at doing this part, who's going to be around, and who's going on, vacation leave or family leave or, whatever, so that we can make sure that we always have coverage so that there's enough people there who can handle all the usual issues that we have and that just kind of happen all the time. We can take ownership of this service because it's ours. It's our small team where we all know each other. We can all sit around one table and talk about our job and talk about our service and make decisions. And so that's where two pizza teams come in, and they work really well. And we see that in the market capitalization of these big companies that do a good job at it. They are capitalized in trillions of dollars. The companies that are not so far down the list, number 10 or 12, are only capitalized in the billions. So, there's trillions of dollars on the line of getting this right, building architectures that we can support large services on by using these small teams so that people can work together. So fascinating stuff. But here's booking.com. Now, how could you use this for your project? Well, the question is, what's the architecture that you're going to use to support that project? Is it going to be a single server kind of a thing where everything's encapsulated into one server, and everybody's overriding each other and working on stuff when they're making changes and things, and chaos reigns when you go to push changes into production that you really aren't meant to work well together. That's a problem. But if you use this sort of microservice architecture, you may have a web tier, or you have web developers that are working on building UX, UI kind of things built into the web server. You may have another server that's the database server. And we leave that, and we put the database server on either a separate physical server or a separate virtual machine, and the database people work on the database server. Web people work on the web servers, database people work on the database server. And business logic people work in the middle on a third server that interacts between the web servers and the database server. That's one way that you can operationalize this crazy architecture that these huge companies build into your small architecture to support your class project. Oops. Now, this one is a reference architecture from Amazon, and so this is all about cloud-based architectures, and you can see it's pretty complicated. And you know that's happened over time in the cloud environments, and particularly for Amazon. Amazon originally started out as an infrastructure as a service environment where you would basically get your own Ubuntu or Red Hat or whatever server, and then you would make changes to the server to make it, you know, deploy services that you needed. Fine, all good, right? That's just the way it was back then. But now what Amazon has done is they have scaled this up and they have added services to the old Amazon machine images that they used to rent out. And now you pay more, of course, for these servers that have additional functionality, which is fine. You know, you're paying for stuff you didn't have to do, and you know, that's all good. But if you look at this architecture, you can see that it's very different from something that you might think of. First, our user traffic comes in through Amazon's Route 53 hosted zone. What that does is Route 53 is Amazon's DNS service. And the neat thing about having Route 53 in there is that you can make changes to your DNS environment more quickly than you could using other systems. One of the crazy things about the internet is that people say if you're going to change the IP address of your servers and you want that reflected in the DNS service, you might have to wait 3 hours before the changes you make get propagated around the internet. 3 hours? This is computing. We do things in milliseconds, not 3 hours. Why is that the case? Well, it's all the caches that exist all over the internet for things like DNS name resolutions. And so, that just happens. Uh, in a When you're not making changes, it speeds things up a lot. But when you do make changes, then it's not really made for change mode. It's made for functioning and resolving URLs to IP addresses. That's what DNS does. So Route 53 just makes that a little bit easier. Then we come into this elastic load balancer. And what an elastic load balancer does is that it sends traffic to the servers that are behind it. And it keeps track of things like which server is more busy than the other server. And then it will send traffic to the least busy server. And there's all kinds of metrics around this and stuff. And we don't need to get into that today. But that's the basic functionality of the load balancer. And that's useful because what that says is, in this drawing, we've got 2 web servers, but we might have 500 web servers. And that load balancer would need to keep track of the concurrent sessions happening at each one of those web servers so that it could take in new incoming traffic and forward it to the server that's least busy or has the most memory or is closer to the user or whatever it is that we optimize around. And that's a useful thing. Beyond that, we've got our app tier. And then after that, we've got our database tier. What is this drawing? It's a 3-tier architecture, just like I talked about before. And then over here, we've got our Amazon S3 bucket. Well, what S3 is a pretty much infinitely scalable storage array. And so we're using S3 as storage for our different servers, including our Amazon RDS, relational database system, down in here, and an elastic cache tier. What caches are is that in a lot of web scale applications, what you find is that the servers tend to serve the same stuff over and over and over and over and over again. Well, why not put that stuff that gets served all the time into a really high speed location? And you know, the highest speed location we have is RAM. And so we'll turn one or more of our servers into caches where we load frequently requested content into the cache that's on board of the CPU, and then we'll just serve right out of that cache and not go out to the servers themselves and just serve out of the cache. That's a really useful thing to do. But anyhow, so you know, this shows you that even a simple concept like a three-tier architecture can get complex when you start using the cloud-based systems that are around to support it. And of course, we didn't even talk about these over here. There's more to it. And you know, and the good thing about this is that if you take the time to become expert in these ideas and techniques, you know, you're going to make a ton of money because it's a hard thing to do. So that's good. We want things to have this, that's called a high barrier to entry. If everything's really simple, you know, like what's the barrier to entry of starting a taxi fleet? Well, you have to buy a bunch of cars and hire a bunch of drivers. That's not that hard to do. And so the barrier to entry of having a taxi fleet pretty low. On the other hand, what's the barrier to entry of developing your own cloud service provider? Well, it's a lot more complicated, and there's a lot more capital involved. And there's a lot more specialized services that need to be around. It's just more complicated. So anyhow, we want things that have a higher barrier to entry because we can satisfy those barriers to entry, and other people can't. The having a higher barrier to entry means that you can start a business, but somebody else can't because they can't afford to you know follow you into that business. Well, let's look at some other services out here that I think will be useful for you as you're thinking about architectures and projects. So one thing that Amazon does, you know, like I said, that these cloud-based architectures are pretty complex. So what they do, uh, I'm slowing way down here, so I'm gonna let it catch up. So what they do, what Amazon does, is they come up with reference architecture. And these reference architectures are just Amazon's way of saying, this is what we think is an architecture that will support this kind of an application well. And so it's not required or anything, but it's just a you know a guideline for you to as you think about how you're going to build this thing, yeah, using Amazon's tools. So here's a search architecture. Amazon Open Search trending queries with Amazon Glue and Amazon Bedrock. Well, you know, I don't know what those things do. I don't know why you would do this. Demonstrates how to leverage AWS services like Glue, Bedrock, Open Search Service, vector embedding, and k-means clustering and LLMs AKA artificial intelligence, to identify top trending search queries for optimizing content strategy, improving user experience, and potentially increasing revenue. Okay, fine. This is complicated. There's a lot going on. And if you wanted to build this, it would be a tricky thing to do. But on the other hand, when you think about your projects, this might give you a little bit of inspiration to think about, how should we approach building the application that we want to build? How can we, cut off a layer of this thing and use it as part of our MVP? So, a useful thing to do. And so these reference architectures are worth looking at and reading about and getting a feel for how they work, just because it can be very helpful. Yeah. Now, here's another one that I think is useful. So this is an IoT application. Well, what is IoT? We have taught in the past a course on IoT, and I think it was just kind of wrong-headed. The course, what you do is you would start with Raspberry Pis, and you would build these sensors. And then the Raspberry Pis, you load an operating system on them, Linux, and then you would add some sensors to them, and then they would report status back, and blah blah blah. I think that's completely the wrong end of the application to think about when you think about IoT. I think the sensor side of an IoT network, think about the parking application that we chatted about before, where you have embedded in the concrete or suspended from a light pole a sensor that would tell you, one thing. It would say, is this parking spot above me available, or is it taken? And that's all it would do. Well, a lot of IoT sensor networks do something similar. A really popular use for IoT is in the preventive maintenance field. And preventive maintenance is what you want to do is well, to use an example. In Dubai, they put everybody has in their the desert villa, they have water pumps. And these water pumps are put in by the city, they're owned by the city, and they have maintenance crews that come around and fix them. Well, here's the problem. If your water pump breaks, it's very inefficient for the city, the municipality of Dubai, to wait for you to call in and say, hey, our water pump doesn't work. Can you send a technician over? That's very inefficient, because the technicians end up spending most of their day just driving around, going from location to location to location. A more efficient approach is to think about, well, let's put sensors on these water pumps so that we can know in advance of their breaking that they're starting to fail. Well, how does a water pump fail? Well, it usually fails by the bearings wear out inside the water pump. So the motor still works. It's just that it's, kind of flopping around and isn't very efficient in pushing water around. Well, a sensor that can keep track of vibrations can feel that in the water pump before the water pump actually fails. So this application, these smart pumps that DEWA, Dubai Water and Electricity. I used to have a lot of students that worked for DEWA, and it's a great place to work, and they liked it. But anyhow, so these smart water pumps would keep track of 3 different metrics in the location where they were housed. One is the vibration status of the pump itself, and that gets at, is the pump getting ready to wear out, and therefore shaking more than it should normal. The other was temperature. Is the pump in a location where it's overheating? And we need to move it to a different location or, blah, blah, blah. And the last one is humidity. If the pump's leaking, the humidity around the pump is going to go up. And so by keeping track of the amount of moisture in the air, then it's another way to keep track of how stable this water pump is. And so then the goal was to say, well, let's send our technicians into this one neighborhood where we've got, 8 or 10 pumps that are showing advanced signs of wear. And the technicians just go from one house to the next house to the next house to the next house and swap out the water pumps before they break. Awesome, right? Let me get back to our application on this. So the question then becomes, where is the application to keep track of these IoT devices? Is it the sensors that exist on the water pumps, or is it something else? Well, those sensors are, they're going to be built by somebody and they're going to build thousands of them at a time and like glue them onto the exterior of the water pumps and that's it. Well, let Siemens do that. Siemens is great at building lots of stuff, and they're great at the hardware side of things. And they can build you really good sensors that you glue on the side of a water pump, and they just do their thing. Well, those sensors are probably going to be using a 5G connection out to a cellular network. Why 5G? It's not because we want high download speeds and stuff. One of the other really important things about 5G, besides the download speed stuff, is that they have these little teeny tiny packets that are available and are designed specifically for IoT devices. In these little teeny tiny packets, they send only a few things, like they would have their IP address, the IP address of the sensor, the name of the sensor. Naming really matters because that's your connection back to where is this sensor, the name of the sensor, the and then the statuses of those variables that it's supposed to keep track of. I'm sorry. IP address, name, time, the time for the sensor, then the statuses. What's the humidity? What's the temperature? What's the vibration? And that's it. Well, that's just a teeny tiny little packet. And that teeny tiny little packet can be transferred across the 5G network very, very inexpensively. And so from the 5G network, it connects into a connection that and on the towers, 5G towers that connect it back to a cloud service provider. And then at the cloud service provider, that's where the application is. And the application is a database that takes these incoming teeny tiny packets, adds them to a database, and then generates reports off of that database that says what's going on with all these smart water pumps. So where's the application in this IoT industrial edge application? It's in the cloud computing center. How would you build it? Would you need a fleet of sensors out there? No. You'd probably get in touch with Siemens and say, hey, any way you could send us a free sensor? And if they did, great. If they didn't, they'd say, but here's our APIs, and you can see what data comes out of these sensors. And then you just, either build your own fake sensor if you want to show how it actually works, or you don't, and you just, build an application that would handle these APIs. And so, where is the IoT application? It's in the cloud. It's got a front end that deals with user requests, and it's got a back end that's a database that takes all these incoming teeny tiny packets and puts them in the right buckets and makes them available to the application. That's a different bird. That's, an application that you guys could build that would be really interesting. So there's that one. That's the IoT side. I saw this one on the Siemens site and I thought, man, what a cool project. You start, I don't know if van life is a thing in Kosovo, but it definitely is here. And some people, go out and live in their vans. I don't know why, but they do. And they go camping and, see the world and all that kind of cool stuff. And I love that. I think that's a lot of fun. I got that silliness out of myself back when I was, my 20s, and it was a lot of fun. So anyhow, you start with like a Mercedes Sprinter delivery van, and then you turn it into your own camping van. Here's where the fun part comes in. What kind of an app, what kind of a network, like a van area network, would you build to support your van life? And what sensors would you want? What kind of computing would you want? What kind of an application? How would you interact with all those sensors in your van life um, application? I think that's cool. I think that sounds like a fun project. Let's see what else we got here. Software-defined vehicles, still on the Siemens site, amazing. What you see here is the chassis for an EV, on an ICE, an internal combustion engine. This is where the engine would be, and it would be a big honking thing that would go up, pretty high, probably up to the top of these shock towers, and blah blah blah. But on an EV, all that's gone. And the motors are housed right down here. Usually they're connected pretty closely to the wheels themselves. And they've got connectors and stuff on them. And what we see here, this big blocky thing, that's the battery pack that has all of that, lots and lots of little like AA batteries in there. And that weighs a lot, which turns out is kind of a good thing because you'll notice how low, like it's just up to her, not up to her knee even, it's kind of up to her calf. Uh, and weight low down in a car is good because it makes it more stable. All good. But interesting stuff. Could you build things to my guess is that a lot of the sensors on EVs are probably built by Siemens. Why not? That's what they do, and they're really good at it. So that would be a good thing to do. The last one here is this is that open source e-commerce thing. So if you wanted to do a Pristina fashion e-commerce site, what do you need to build? Well, here's the technology that takes care of the back end stuff. What you need to concentrate on is the front end stuff. And maybe that's the more interesting part of the application for you. And finding a way to merge these two things together. I love it. What a great project. And this is from Odoo, ODOO, right up here. And I think they're a Buffalo-based company. So I had a student in my class in the summer who worked for Odoo, and it's a good place to work. So whatever. But there's lots of different things. These e-commerce backends that are available. WordPress has one. You find a whole bunch of them. Just search for them. But so e-commerce becomes a different kind of a project where you can concentrate more on the front end than on the back end. buy, lease, whatever, the back end technologies if your expertise is on the front end. And that's what this kind of a project would be. So anyhow, I think we're going to end there because I'd like for you guys to be able to get together in your teams and at least check back in, make sure everything's coming up right. Don't forget to sign up for your gate review presentation slot. You've got lots of time. We'll probably do, three teams per day. And I think that'll take care of us if we've got a fourth, and you have to go and one.
Professor?